Good afternoon, everyone. Very excited to share my work on cultural competence of VLMs. I'm a junior CS undergrad from KP University, and I've done this work with my advisor from ICCV ASI. So VVS, if you don't know, it's a city of Competence in India. So this is right. Okay, so first we're going to look at why exactly there is a need to study the cultural competence of VLMs. So VLMs are going global. 8 of the top 10 AI models are now VLMs, with the exception of UCR1. And if they are not culturally competent, then we can only go for like full global deployment. And what we are seeing is that cultural competence is not new. There has been lots of work going on, but most of them are text only. And the ones that are multimodal, like they are actually taking a look at images or audio, they only study whether VLMs know about certain cultural specifics. CVQA is a very important paper. They study cultural competence from a VQA perspective. So it's only the model saying that, yes, in an image, this is a certain cultural point. They are not going into the depth of whether these models can actually take this knowledge and write outputs that actually give us a very nuanced understanding of the perspective of the cultures. So that is what we are aiming to address with this one. Since there is almost no study in a downstream point of view, we're probably going to be the first one to do it. Okay, so with that out of the way, let's look at the question that we're trying to answer with our study. So first off, we are trying to understand whether like the cultural cues that are in the prompted text as well as the image, they actually end up in the outputs. And if they end up in the outputs, then are they actually using culturally specific vocabulary terms, or are they like generic? And if all of that happens, then actually like, we finally are going to look at the image because we are studying from a multimodal point of view. So if there are cultural cues in the images, do they actually come out in the outputs? Do they actually influence the outputs? So, yeah, so this is our entire methodology. It could look a little overwhelming, so I'm just going to go step by step. So first off is how do we select which cultures to study, which nations to study. So for our work, for culture, we are going to use nations. So if we're going to say the United States, then we're going to assume that the United States is one culture. Similarly for China, that will be considered as one culture. So we only studied in English because English is the widest language out there. And we selected the top 42 countries because that gives us a very good 81% of all English speakers are covered. And we also did a calculation of the global landmass, and over 60% of it is covered. We also got very uniform distributions among all of the continents, other than Oceania, which has very few countries anyways. So moving on, following previous work, like text only, we selected the children's story generation task, and we have 35 topics on which we will be generating children's stories for our evaluation. Okay, so how do we collect the images? So first we have a search term, so that's going to end up since we have concepts like honesty, collaboration, they will end up with search terms like honesty for Chinese kid, something like that. And then we are going to get 3 images from Google search. We are going to scrap them with Beautiful Soup, and then we are going to store them. And then to ensure that these images are actually high quality, what we are going to do is we are going to have a human look at them. And among the 3, only 1 will be finally chosen. And if all of them are irrelevant, then we'll go and we'll scrap more images. So once all of that is done, we have the data set ready, and then we just go in and ask the VLMs to generate our stories. So it's a very simple prompt, and the based on the image part is important because we're actually asking the VLMs to look at the image and make a story that is related to that. So if you look at the kind of stories that have been generated, yeah, so this is a Demo 312B model. So these are like 3 different cultures. We have the United States, India, and Germany. And these are a few lines of the stories that we generated for each of them. As you can see that the model is using very relevant names and vocab, like Lederhosen there is for Germany, and also for India, like Solvings and busy streets, which makes sense. Now let's start to look at it and throw some numbers into how exactly the performance is. So how do we do that? We do 4 different studies with all of the stories that we end up getting. And we correlate them with established cultural frameworks like HCD and WVS. We chose them because all previous work overwhelmingly use HCD and WVS. A few citations are here. There are way more in the paper. There are almost 10 papers that are using the same frameworks. So moving on, first test will be lexical diversity. So we'll study whether the wordings differ from the story to story, from culture to culture. So in that, we first calculate the normalized WER, and after that, we do a TF-IDF ranking to find out which are the most popular culturally specific words. And with that done, we want to understand whether the stories actually make sense, like whether they're culturally competent. So we do that with CLIPScore correlations. We choose this because other metrics like bird score and all, they have been shown in the previous literature to not be very good for encoding culturally relevant words. So blue score is lightweight and it also gives us good results. And from the multimodal point of view, we get CLIPScore correlations. So the implementation is very simple. The motivation is that since CLIPScore measures how similar an image is to a text, since we have made sure that the image is culturally relevant with a human annotator, so we consider that the gold standard, then we can get the CLIPScore similarity between the image and the text. So if the text that was generated by the model is culturally competent, then we should get a high similarity. So that was the motivation behind choosing CLIPScore. So let's dive into it. So we can start with lexical diversity first. So moving in, we saw like within nationality and across nationality WER. So within nationality means that for India, we took all of the 35 concepts and we averaged them. And for across nationality, it was like, let's say all of the countries together. And then we got them by the model. So we can see that across nationality, the variance is much higher consistently for all of the models regardless of their size. And this means that there is significant difference in the wording that the models are using in the final outputs that they're giving. So that means that the stories are different. But let's now try to understand that whether this difference makes any sense. So moving on, we know that there is some difference, but is it statistically significant or is it a complete probability? So for that, we did some ANOVA testing. All of the models rejected the null hypothesis, and we found that within nationality, it's like 50-42. It's like significantly lower. Even the small watch model KM312B, it's 1,540 times smaller than across nationality. So there's quite some difference. This is not probability, and this is actually consistent. Okay. So now let's look at the common words that have been used by the models. So we can see that the name of the country was in the prompt. So we expect the model to use the name of the country in the final response, and it did that. I'm showing two different models here. All of we present the table for all of the models in the paper. You can check it out. So the name of the country is present in almost all of them. But alongside that, we also see more words that are also culturally relevant present in the stories. JMOS3 and VLP and Internet VL3, these are two models from two corners of the world. So this behavior generalizes across all of the models that we have looked at. So this means that models are using richer vocab that actually makes sense. This is not just what is in the prompt, like it is going out of the way and including more relevant words in the outputs. Okay, so now that we know that there are certain differences in the outputs, we should look at whether the differences make any sense, like whether there is a semantic meaning behind all of these differences. So let's look at that. So we studied HCD and WVS. So we got the blue score correlations and we found that some interesting patterns. So I'll start with the first graph over there. So that is our HCD. So what we do is we see that it is a random and the shuffle baseline. So over those baselines, how the model is improving. We see that KM3 and Internet VL3 are actually showing negative correlations. What that means is that it's quite the opposite of cultural competence. It means that cultures that are different, quite distinct from each other, they are making similar stories. So that is concerning. But for WVS, what we see is that almost all of the models are around, the correlations are around 0. And they're also not improving at all over the random and shuffle baselines, only the variance is 1. So that is also problematic. It means that WVS is measuring something completely orthogonal to what we are trying to study over here. And in a way, it's not really helpful for our study. So we're going to proceed with HCD and get into the details of what it actually means. Okay, so in this model we can see that KM312B gets negative correlation from the HCD consistently across all of the countries that we have studied, with the only exception of one Scandinavian country over there. But if you look at small VLM 2.2b, it's even more interesting because HCD gets positive correlations on all of Russia, Europe, and China. But if you look at WVS, which is not giving us very good answers, not very good numbers, we see a completely different pattern over here. Canada, Brazil, and Australia, and Germany are the only countries that get positive correlations. Now the funny part is that two different sets of countries are getting positive correlations with two different cultural frameworks. So it means that small VLM2, because it's a small model anyways, it's actually producing stories that are quite different and different models, different frameworks are taking up different kinds of patterns. It's not generalizing well, unlike KM3. Okay, moving on. Okay, so now let's talk about the multimodal point of view. So over here, we also see that the correlations are pretty weak. It's between 0.06 and minus 0.06. But we see that small VLM2 over here, unlike the previous chart in which it was all over the place, small VLM2 consistently beats gamma 312B's results. This is very problematic because we did a human study in the paper. You can find out the details if you go through it. The thing is that small VLM2 does not really write very good stories. It's a small model. It has a dual tower kind of hacky approach. Anyways, the outputs are problematic. They are stereotypical. They do not represent the culture authentically. And given that this CLIPScore-based framework that we have designed is telling us that this model is actually better in terms of cultural competence, it actually becomes problematic because in that case, we are trying to show gamma 312 in a negative sense, but it actually writes much better stories. So with that out of the way, is our method completely useless? No, it is not. We have implemented a different sort of technique and which we calculate the recall. So the motivation for this is very simple. If the story and the image, if the story is derived from the image, then we should be able to go back to the image from the story itself. So with that, we again do within and cross nationality to understand how it varies because we are studying with nationality as a cultural landmark. So what we see is that for cross nationality, the numbers for recall at 1, they're consistently close to the random baseline. So we cannot go back to like an image of a different culture from a story of a certain culture. But if we look at within nationality, it is much higher, almost 2,000% higher. This means that CLIPScore can actually tell us like whether there is some sort of connection between the different the outputs that you get from an image and text, and if we feed it to a VLM. Okay, so with that out of the way, that was all that we implemented in the paper. It's still a very baseline approach. We found that there are some problems with the metric that we have implemented. But yeah, let's see what we actually saw. Let's summarize it now. So we saw that VLMs are showing cultural competence, but it is problematic. The thing is that we found that like if we go through the stories that there is they are using appropriate words, but also like some models are showing negative HCD correlation. So what happens is that more distant cultures like US and Canada, the cultures are very similar, right? But the thing is that their stories are not that lexically diverse. But if we look at very distant cultures like US and India, they get very similar stories. That is problematic. That is the opposite of cultural competence, right? So we don't want that. So that is one kind of an insight that we can get from our work is that not everything, not all of the models are still up there in terms of cultural competence. And also, like from the multimodal point of view, we found that CLIPScore gives us problematic outputs, and we hypothesized based on that because CLIP and SIGLIP that encoder that small VLM2 uses are very similar. Maybe the model, this same family could inflate the similarity scores. But yeah, this is more testing across more architectures like Dino and CLIP. But for now, we found that CLIP is a good baseline to actually get started in this direction, and then maybe develop more better methods and actually fix the bias that we have discovered. So yeah, we set a baseline and we aim to improve based on whatever we have found so far. And so yeah, for now I'll be open to any feedback and questions that you could have. And also this is we're just starting out with this project. We just implemented a baseline, so any form of feedback would be helpful, and if you have any questions, I'll be happy.